Okay, in this next example, we have an integral with an even power of sine x. So again, you can see that we can use the standard identity, which is sine squared x plus cosine squared x equals 1. And then if we wanted to use sine squared x and then find 1 minus the cosine squared x and substitute. But unfortunately, this integral is no simpler to evaluate. So what we can do is we can take advantage of the half angle identities. So here are your half angle identities, and we want to be able to then use those to be able to solve this particular problem. So if we know our lower limit's going from 0 to pi of sine squared x dx. Okay, so now using our substitution for our half angle identity, going from 0 to pi, instead of writing sine squared x, we can then write 1/2 times 1 minus the cosine 2x dx. And from here, we can actually integrate. So we have 1/2 times x minus 1/2 the sine of 2x, going from 0 to pi. So now we can go ahead and solve this definite integral. So what we have is we have 1/2 times pi minus 1/2 sine of 2 pi minus 1/2 times 0 minus 1/2 times the sine of 0. So now we can go ahead and then distribute. So we're going to have 1/2 pi. Well, regardless, sine of 2 pi is going to give you 0. Minus 1/2 times 0 is going to be 0. Plus the sine of 0 is 0. So then our answer is 1/2 pi. Now, in this case, we've mentally made the substitution where u is equal to 2x when integrating cosine of 2x. Another method for using or evaluating this integral was in exercise 35 on section 5.6. And then we can use a similar strategy to integrate powers of tangent of x and secant x using the identity secant squared x equals 1 plus the tangent squared x.